All right, so first thing, now that we have our blank worksheet, we've gotten past that, put our name. What are our colors that we're allowed to use? What are the colors you're allowed to use on every worksheet, no matter what? Blue or red. On the quiz, blue or red. On everything for me, your writing is supposed to be in blue or red. So I see that some of you are not writing in blue or red for some crazy reason. You're not following directions. So be prepared that you're not getting full credit, because it's no different than if someone else in authority asks you to do something. There's a specific reason. I've gone over why there's a reason. You need to follow directions. Okay. What do you mean you don't have this page? On the assignment, there are two. One that was shared with you that you deleted. The other one you open in Cami and save to your assignment. I said that like 3 or 4 minutes ago, and that's why a whole bunch of people attached it when I told them to. So Christian, Gael, Rachel, you guys need to get the correct worksheet attached. I told you, delete the wrong one. Mario, get the correct worksheet attached. Angel, get the correct worksheet attached. I told you, delete the one that was there and go get the second attachment, open it in Cami, save to your drive, attach to your assignment, so that you don't have one that's already filled in. Okay. So like I said, this is stuff we've already worked for. We worked with tables already. So I think I'll be ready. Type my name. Put that it's period 3. Okay. I'm working in red. Now, we have this boy, his name is John, and he likes the redwood tree. So he found a table about the redwood tree, and he was wondering, can he predict what's going to go on with the tree using the table? So when we're working with the table, first things we always have to do is we have to find out our differences. We've got to go make our connection for the 3 years after to 4 years after, 4 years after to 5 years after. We did this before, so you know what we're doing. You want to narrow it down. So everybody should attach that new worksheet. I already said that. So I see that there's a change, right? I see a change. How much is the change in the year from 3 to 4? What's changing? Yeah. Okay, we're adding a year. And then from 4 to 5. From 4 to 5, what are we doing? What am I looking at here? Okay. Guys, come on. Remember, the chat tells me who's participating, and those people that are participating get full credit. So I'm going from 4 to 5, year 4 to year 5, adding another year. Then we have to look at tree growth. What is my change from year 3's growth to year 4's growth? How much change was there? Okay, for what? What are they measuring it in? 4 feet. Okay, and from year 4 to year 5, what are we measuring in? And how big is it? What was our change from year 4 to year 5? Another 4 feet. Okay. So whenever we approach tables, we always have to do that first. Okay. Because it's that information that answers the first question. How much did the tree grow each year? So we have to use a sentence. The tree grew about, oops, right idea, wrong thing, text box. The tree, I want red. Grew about 4 feet per each year. Okay, we just took the words in their question and rearranged them. Why did I say this word about? Why did I say about? Why did I say that word about? Why do you think? Why do you suppose we use the word about? Yeah, because I mean, we're estimating. I mean, it's kind of really hard to actually measure the height of a tree. So it's close. They're using some calculations and stuff, and it's close. So that's why they're saying 4 on the table, but really it could be slightly different. So we use about because we're not 100% sure. We're giving it an estimate. Okay, now it asks, how tall is the tree 2 years after planted? Now, our table only starts with 3 years. Our table starts with 3 years and they want year 2. So what do we need to do to solve for year 2? We have to backtrack in our table. So what math are we going to do to figure out how much it was for year 2? We're going to be subtracting from what? What thing are we going to be subtracting from to figure out how tall 2 years after it was planted? Subtracting from what to figure out how tall? Okay, we said subtracting. Subtracting from what? Subtracting is an operation. It's not what you're subtracting from. What are we subtracting from? What piece of the table are we looking at to figure out tall of the tree? Okay. Marissa said subtracting. Subtracting from what? What piece of our table are we looking at for how tall? The height. Okay, so what number are we going to be subtracting from then to figure out year 2? From the 17. So 17, take away the, how much are we subtracting? the 4. Means that in year 2, it was how big? And what are we measuring by? $13 feet. Yeah. Okay. So that answered the year 2. Then they want us to do year 7. So what are we going to have to do this time? Are we going to be subtracting to find year 7? No, we're going to be adding. Adding to what? Do we have year 6 even on our table? No, so we have to figure out year 6 and 7, right? We have to figure out year 6 and year 7. So what am I going to be adding to find year 6? What am I going to be adding to find year 6? The height of the tree, but which height of the tree? The 25. Okay, so we have to do 25 plus 4. That's my year 6, right? And then we have to take that 29 and add another 4 to get me year 7, right? So this is my year 6. This is my year 7. This over here was my year 2. Okay, now that I've done all the calculations, I have to do my sentence answers. Okay. The tree was, because it's past tense, about 13 feet tall. 2 years after it was planted, the tree should be about 33 feet tall, 7 years. Oops. After planting. Okay. Questions about that? Yes, you have to show your math if you're expecting to get full credit. Okay. So how tall was the tree when it was planted? So we have to figure out what year would that be? What year would it be the year he planted? The year it was planted, what year would that be? Because these are years after planting. So what year would the year it was planted be? How many years after planting is it when it's planted? How many years after planting is it the year we planted? Think about that. Is it years after if we've just planted it? So what number are we going to use for the start year? if it says number of years after planting, when we first planted, has there been any years that have gone by? If we just planted, have there been any years that have gone by? If we've just planted it, have there been any years that have gone by? No. So what number do we use for no? There's no years that have gone by. Yes, 0. So they're asking us to find year 0. Okay. Only catch. Do we know year 1? Do we have year 1? No, we do not have year 1. Could we find out year 1 by doing something to the numbers we've already done? What are we going to do to find year 1? Because we need year 1 to find year 0. Subtract what? From where? Be specific. Subtract what from where? Subtract 4 from 13. Yep, 13, take away 4, because that was year 2 minus the growth for year 1. So we're going to say that's 9 feet. And then I use that in a chain reaction to find year 0, right? Just like I found year 7 by chain reactioning with 6. We have to find year 0, the start, by chain reactioning with years 2 and 1. Okay. And then we do our sentence answer. The tree was about 5 feet tall when it was planted. Okay. So, about how tall do we think the tree is going to get in the year 50 after it's planted? About how tall do we think the tree is going to get by the 50th year after planting? This is just an estimate. We don't need to know the exact number. So what are we going to say about how tall do we think it's going to be? Without doing any calculations, without doing any of that, about how tall do we think it's going to be when it's growing 4 feet each year? About how tall are we going to say it is? Someone give me an estimate. What are we thinking? About 200 feet? Okay. Yeah, because, 50 feet, about 4 a year. Okay. So the prediction for how tall it will be 50 years after it is planted is about 200 feet tall. Okay. So we've done stuff kind of like that. Now, John decided he wants more information. So he decided he wants to graph what they're talking about. He wants to graph these points. So we need these data points. Okay. We said at year 0, it's 5 feet tall, right? At year 1, what was it again? At year 1, what was it again? 9. Okay, thank you. At year 2, what are we going to say? $13. At year 3, $17. At year 4, $21. At year 5, $25. And I noticed his table is only going through year 6. So I'm only going to worry about through year 6. Year 6, it was what? 29. Okay, so we got to take these points that we got from the table, from the calculations of the table, okay? And we're going to plot them on the graph, okay? So go put our dot, it'll be red. At year 0, it's 5. Now, I noticed they did not make it easy and put a 1, 2, 3, 4, 5 on here. So I'm just going a little above the 4, okay? A little bit above the 4, a little bit above the 8. Okay. So I'm going slightly above the one that I see there. Go put your dots. Year 4, year 5, and then year 6 is going to go slightly above the graph. Then I'm going to go back and get the coordinates, put them on the graph. That was 0, 5, 1, 9, 2, 13. Now remember, you don't have to keep going over to the side and grabbing a text box. You just have to, once it's lit on the left side, you just have to double click out in the center and the new one shows up. Okay, so we got our dots on there. We got our coordinates on there. Okay. Okay. Now it asks us a question. We plotted the points, right? What does the graph look like? What is its shape? So what are we going to say? What is its shape? What are we going to say? Okay, so the graph looks like a straight line. Okay, that handles that question. Does the graph represent a proportional relationship? So based on what we've already learned about what makes it proportional and not proportional, what are we going to say? Is it a proportional relationship? Why or why not? Is it a proportional relationship? Why or why not? Oh, it's not proportional because it doesn't go through the origin. It doesn't go through 0, 0. So the graph does not represent a proportional relationship because it does not start at the origin exactly, which is 0, 0. Okay, we learned that last chapter. It's one of the things we learned last chapter. Okay, does it make sense to connect the points? So one of the things you need to learn about graphs is you only can connect the points if it makes sense to have a part of something. Okay, and it still counts. Can I do part of a foot? Can I do part of a year? If I can, then it makes sense to connect them. If I can't, then I don't. An example of a don't situation is number of children. You do not have 2.1 children, right? You have 2 or you have 3. You have fixed numbers. You don't have these in between values. Okay, so always when you're looking at the graph, we need to label what the parts mean. What are these numbers 1, 2, 3, 4, 5, 6 at the bottom stand for? What do those numbers at the bottom stand for? A couple people who are arguing with me about getting their cameras on, and it's really kind of irritating in week 6. What do those numbers at the bottom stand for? The years. Okay, so we're going to add that into our graph. So we see, so this is the number of years since planted, right? What do the side numbers mean again? What do the side numbers mean again? The height, how are we measuring it? How are we measuring it? In feet. Okay, so the height in feet, let me see if it'll let me do this. Oops, where'd it go? I'm gonna see if I can write the text box and take it over and swivel it. Let's see. Height in feet. Can I take you over here and spin you? I mean, some of the other programs let you do that. Well, we're just going to put that up here. That'll work. So we know that the Y stands for the height in feet. The X stands for the number of years since planted. Can we have part of a foot? Can we have part of a year? Both have to be true for us to connect the points. Can we have part of a foot? Can we have part of a year? And the number makes sense, you know. Because hypothetically, we could have part of a child, but it doesn't make sense. You either are a complete person or you're not. There's not really an in between. If they were counting how many trees, number of trees, you can't have part of a tree and have it count. Okay. So does it count? Does it make sense that when I'm going from year 0 to year 1, I could be any time value between start and the first year because I can have part of a year, and I can have any height because I can have part of a foot. Can we have part of years and part of feet? Can we have part of years and part of feet? Can we have part of a year and part of a foot and have it make sense? So what if I said that in the first 6 months? Does that make sense? Half of a year? Is that a possible number? Is part of a foot a possible number? We don't have parts in our year? Okay, we do. As long as we have parts of, then we can connect. So I could figure out if I wanted to 2 months in, right? By going and figuring out where 2 months is and going up to my graph. Okay, so you only connect the dots. You only connect the dots if both measurements can be taken in parts and still make sense. If I'd been number of the years since planted and number of trees, it wouldn't make sense to connect them because we wouldn't have 1.2 trees or 5.7 trees. There's either 4 trees or 5 trees. Okay. So when you're looking at connecting, if it can only be a 1, a 2, a 3, a 4, and make sense, then you can't connect them with a line. If you can have 1.1, 1.2, 3.6, and it does make sense, like part of a foot, part of a year, then yes, connect. So yes, we can connect these because we can do part of a foot and we can do part of a year. Okay, let's go get our line. Remember, I click on the bottom one, pull it to the top one, our line. Okay, so it does make sense to connect the points because we can measure part of a year and part of a foot. Okay. I want that to be red so I can fix it. Red. Okay. So we only connect when both measurements can be taken part of. According to the graph, what was the height in 1.5 years? So I need to go get my line. I'm going to make it a blue line because I'm going to go 1.5 years up. And I'm going to come over and I'm going to estimate what that new dot, which I'm choosing to make blue so it stands out. We're figuring out about, from the graph, about what that new coordinate would be. Okay, who wants to venture to guess? What maybe are we going to say this new coordinate is at? (1.5, comma what? Now think about how we're measuring. How many feet did it grow in 1 year? Did we estimate? And isn't half a year going to be half that number? So it would be half the number between the 9 and the 13. That's how we're estimating. That's how we can use the table, the graph, to help us estimate, because it's halfway between. What number would that be? Halfway between 9 and 13. Halfway between 9 and 13 is what number? Halfway between 9 and 13 is what number? 11. So we would say that this is about 1.511 because half of a year is halfway between. Okay, so according to, oops, sorry, keeps doing that. According to the graph, the height of the tree 1.5 years after it was planted is about 11 feet. And that's because I know 0.5 means half. So I'm looking at halfway between year 1 and year 2. And I knew I went 4, so I just took 9 plus 2. And I want this to be blue. Trying to make him stand out on the, so he's different. Okay. Can you use your graph to predict the redwood tree's height after 20 years? Why or why not? Are we going to be able to use this graph to predict 20 years after, like we predicted 1.5 years? Are we going to be able to draw a little box like that to find the point that's 20 years on the graph? We're not talking about doing the adding 4 in. We're not talking about that. We're talking about looking at this graph. Would I be able to use this graph to find the 20 year? Would I be able to use this graph to find the 20 year? No, why can't I? Why can't I use this graph to find the 20 year? Because it only goes up to year 6. Exactly. Okay, so I cannot use the graph. I cannot use the graph to predict the height of the redwood. All I'm doing is the exact same words they gave me. Tree 20 years after it was planted, because the graph only goes to year 6. Okay. Should kind of make sense. Could I use the adding up thing? Yes, but that's not what they were asking. They're asking about the graph, specifically about the graph. So John is still not satisfied. He wants to see if he can figure out some way to find out the height of the tree, no matter what year it is. So we're going to fill in our table with what we already know. What was its height at year 0? What was its height in year 0? Five. Okay. What was its height at year 1? 9. 2. 13. 6. 29. Okay. So if you have not done so already, can you write an algebraic rule for the data? Okay. So when we make our rules, go back to what we started with, right? We found out the distance in feet, right? We found out that this was +4 over and over and over. Okay. That change to the y is what goes with the x variable, because the height is the y. Text box. The height is the y. The number of years is the x. So this change of 4 goes with the x. 4 times x, right? It was every year 4 more, every year 4 more, every year 4 more. Okay. Are we okay with that? We understand that part of it? Now, to find the part you have, the second piece, we have to look at what's happening downward as well. This change down is what's going to tell us what we have to add in as our starting value. Our starting value matters. So how much are we adding in to that times 4? Because I know that 3 times 4 doesn't make 17, does it? No. So we had to have added something in to the times 4 number. What are we adding into the times 4 number? We're adding in where we started. Where are we starting our tree? What's our tree start value? How big was it when we planted it? That's our start value. How big was our tree when we planted it? That's our start value. Okay, 5. So we're adding 5 and multiplying by 4. So our equation would be the algebraic rule. It's hard to, I always have to sound it out. For the data in the table is y equals 4x plus 5. Because it was 4 times 4 times, 4 over and over. And then we had to add the 5 feet that it started at. Okay. Now it says we're going to use that rule to check our 50-year prediction. So we're going to use the rule y equals 4x plus 5. And we're going to put in our x equals 50. Okay. That 50-year prediction, that 50, that's the x. And they want us to know to check the y. Okay. So I'm going to stick in that 50. I'm evaluating, just like we did last chapter, when x is 50. Okay. And we have to do the math. Some of you are not doing the math for your worksheet, so you're not getting full credit. 4 times 50 is how much? 200. But I have that plus 5 because remember it started out at 5 feet tall. So how tall is the tree supposed to be how tall? 205 feet. Okay. Now we have to do our sentence answer for it. The tree is about 205 feet tall, 50 years after it is planted, which is not unusual for a redwood tree. Now, how close was our prediction? How close were we on our prediction? How close were we? Because we had originally said, back here, it said the prediction of how tall the 50 years is we said 200. But we found out with the rule that it's really 205. How close is that? My prediction was 200 feet. Okay. this is very close to the actual size found with the rule, right? You did pretty good. Okay, are there any questions about that? We got really close. It was pretty good. Any questions about that? So turn it in. Make sure that you delete the other one that was the wrong worksheet and then attach the correct one so you get credit. Because if I only look at the first attachment, and if it's my attachment, you get a 0. So you want to delete the one that was wrong, and you want to go ahead and make sure you've attached this correct one. That says review and preview. That is homework. That's not part of this assignment. No, this. Review and preview is homework. Go ahead and cross it all. Okay, turn in the notes. Make sure it's the one you actually wrote, not the one I wrote. Delete the one that was wrong. So if I still see my name on it, I'm going to assume that you did not do your work because you were to delete the wrong one and start from scratch with yours. And I see a few people already who did not attach theirs yet. Mine is still there, so they're going to be getting a 0 unless they get theirs attached. Okay, let me see if the homework assignment is out there. So make sure you've deleted the wrong worksheet and attached the right worksheet so that you get credit for doing your work, because I'm not going to give you credit for my work.